Wondering, folks. Let's see. I am not hearing, but that doesn't mean anything. Let me ask people to make sure we are hearing you. These headphones are hilarious. I'm checking with one of my team to make sure that they can hear. Folks are saying they cannot hear you, David. So can you just double check that you're... Oh, wait, I think I hear...
Yeah, let's try this again.
There.
Helps if I click the right button, right?
I mean, I wasn't going to say anything. Awesome.
Problem exists between keyboard and chair.
There you go. Exactly. Although, are you on a stand-up desk? Because
yeah,
and there's no chair.
Yes. Yes.
Fantastic. Awesome, David. Well, I'm going to move you to your talk, and let's get started because I want to know how to improve my legacy code, of which there is a lot.
Where's my share? Mark, help me out here. Oh, there it is.
And I'll just let you know and make sure.
We ready to go?
Perfect. I see it. Cold Fusion Modernization Challenges. Let's
Beautiful. So first things first, I want to thank Mark and Apoorva and Kishore, the whole team at Adobe, for putting on CF Dev Week once again. Fantastic sessions that have already taken place and are coming up. So, of course, they brought me in to bore you with some legacy code stuff while all of these fantastic new technology talks are taking place. So welcome to my presentation titled Cold Fusion Modernization Challenges. This is improving legacy code while retaining your sanity. I created this presentation because every Cold Fusion developer I've ever worked with is a builder and an artist. And what I've found is we want to create and craft these beautiful, elegant solutions with Cold Fusion that are powerful and dynamic, but sometimes we still need to deal with that legacy code that was built a decade ago by a developer who has long since left the organization. Maybe they didn't know what they were doing to begin with. Maybe the company direction has shifted once more, and what was a priority in the past is no longer relevant. Maybe the approach that they originally took to a problem can be done cleaner, more efficiently. Maybe there's new functionality in Cold Fusion that renders old approaches obsolete. At some point, modernization of your approach becomes necessary to retain your sanity. But let's call this what it really is. This is group therapy. Now, why? Because we have all been there, okay? Every single every single developer that's here at CF Dev Week 2022, at some point or another has needed to maintain or develop a legacy application where we hated every single second of it. In fact, many times when I'm working on a legacy app or viewing some older code, I find myself making this face. And I'm not exempt here. Half the time I make that face looking at my own code that I've written, 6 months, a year, 5 years ago. So today, we're going to approach how to improve these legacy applications by asking and addressing 3 questions, okay? First, what are the most common frustrations when dealing with a legacy application? How are these conditions caused? And what can we do to mitigate these causes to prevent them from happening in the future? And I am going to sprinkle memes throughout the entire presentation, because if we can't laugh while we're dealing with these frustrating problems, we might just kill ourselves. And I promise to try not to give my presentation just by reading a bunch of slides. I'm totally going to fail at it, so just expect that to come up. A little bit about me. My name is David Byers. I'm an Adobe Cold Fusion specialist. I've been developing websites and applications for over 25 years. I have been active on the Cold Fusion development community portal at coldfusion.adobe.com, although I haven't been lately because, frankly, life gets in the way. I'm a raconteur. All that means is I tell stories, as you will quickly learn during this presentation. I live in Las Vegas with my wife and a zoo full of animals, including 3 cats, 3 house bunnies, 2 bearded dragons, and now 4 hermit crabs. Why? Because my wife is convinced we're running an animal rescue, and believe me, those animals rule the house. I come in a distant 8th or 9th. But anyway, back to our situations that cause us to make this face. Let's talk about legacy code for a second, make sure we're all on the same page. So how do you define legacy code? Well, some might say that legacy code is code without tests. Sure, it's accurate, but code with tests can still be considered legacy code. Some might say that old code is legacy code. Old is relative, though. I just spoke recently with a developer who said that he was working on legacy code that was written back in 2017. And I thought, oh, you sweet summer child. Some might say that undocumented code is legacy code. Sure, if the knowledge of the code or how or why it was written isn't documented, it could be considered legacy. How about code that isn't currently being developed against? Absolutely. Code that's stagnant and is not actively maintained is definitely legacy. Maybe it just works perfectly for what it's designed to do. Maybe it needs no maintenance. Maybe the developer left. Maybe it's a matter of resources. There could be multiple reasons why it's not being actively maintained, but it's becoming legacy code. Code that's been in production and has been field tested. This is code that's out there, maybe actively developed against, but has been there for a while, becoming legacy code. Cruft, actual word, look it up, means badly designed, unnecessarily complicated, or unwanted code or software. I use that all the time, and people look at me like, Cruft? The hell is Cruft? It's Cruft. Code that isn't tracked by a code management system like Git or Subversion, yes. All of these things absolutely could define legacy code. But to put us all on the same page, let's agree that legacy code is code that we didn't create, or we don't completely understand, or we don't agree with how it was built. Therefore, we're not 100% comfortable modifying it or maintaining it. In fact, many times when I'm dealing with a legacy application, I look at what's there and I say, I could eat a box of alphabets and put better code than this. I say this regularly, and like I said, I'm not exempt. Sometimes this is about my own code. Now, let's get the bad news out of the way. What's done is done. Your legacy code is sitting there like a big steaming pile. It's not going to get any better unless you make it better. Anyone who tells you that there's a quick and easy fix, something that you could just click on to improve your legacy code, they're selling you something. Why? Because there's no magic bullet. There's not any one thing that's going to improve legacy code. The only thing that improves legacy code is hard work. It can be daunting and it can be discouraging. However, there is good news. The good news is I'm not going to tell you anything that you don't already know, but I am going to validate all your frustrations and give you arguments to explain why maintaining that legacy application takes so much time and can be so difficult. The other good news is that your application got you this far. It has to be doing something right. It can't all be crap. Another great thing is that there's 100% opportunity for professional growth in maintaining a legacy application. You are going to learn better ways of coding by working on improving a legacy app. And finally, the information I'm about to provide applies to development in general. It's not just CFML. So this will apply to any coding that you're doing in pretty much any language. So let's address the first question that I posited in my approach. What are the most common frustrations when dealing with a legacy application? I asked a community of over 1,000 developers, mostly Cold Fusion, the following question. I said, what are your biggest challenges in maintaining a legacy code base or application? The results, as you can imagine, weren't unsurprising. 37% said that the application grew over time. It wasn't well thought out. That makes sense. 26% said there was no documentation or code comments to their code. Of course, we're all better at writing code than we are at writing docs, I can tell you that. 9% said that their biggest challenge was that their application had no framework. Another 7% said it was because there was no source control. 5% said that their biggest challenge is that they were working on an old version of Cold Fusion. Another 5 said that it was because the original developer for the application was no longer available to use as a reference. They didn't have anybody to ask questions of why things were built the way they were. The rest of the responses, 11%, I'm going to lump into a category called Other, because it just contains some less popular one-off responses like technical debt or siloed knowledge or non-meaningful variable names. All valid frustrations. However, if you look at the fact that the second, third, and fourth most popular answers, no documentation or code comments, no framework, no source control, all cater to the same kind of issue, then the top 4 answers represent just under 80% of the biggest challenges to maintaining a legacy application. So I'm going to focus my effort on those. Okay, let's look at the first one. The application grew over time, wasn't well thought out. this represented more than a third of the responses that we got. I asked the same group of developers, how many times has a project been given to you with a complete and thorough understanding of everything that it needs to do? No changes needed whatsoever. You're not going to be surprised by the results. Most people responded never. The rest, they also responded never, but I wanted to have more than one color in my stupid little pie chart here. You know why? Because it doesn't happen, period. Many times we as developers, we're building applications like this. We're chugging along as fast as we can, and the priorities and the new requests are coming just as quickly as we can get the work done. As a result, we're forced to take that standpoint where getting the job done is more important than perfection, okay? Sometimes that's a good thing. Perfection is difficult to achieve, and perfection is the enemy of good. However, when you're up against a deadline, time is the essence, more and more corners are being cut just to get the job done, it can be detrimental to the development of an application. Why? Because most application development is organic. These applications grow over time, and if they're not well thought out, they don't really start as well-formed things. They're not really fully formed things when an application is first thought of. They start off as seeds. And then as we develop, different things grow out of that process. Priorities change. Business needs change. Sometimes it's like a cat chasing a laser pointer. And many times stronger applications come out of that process. But at its core, development is a very organic process. If you don't continuously feed and nourish your application, it starts to wither and die, okay? So it's important to understand and ask the question, how are these conditions caused? There's a million different reasons for it. They're all completely valid. Maybe the idea wasn't fully fleshed out before the development began. Maybe the requirements changed. Maybe the proper stakeholders weren't involved in the planning. Maybe the marketing department came up with what they think is an amazing idea or feature for whatever software you're building that users would love, and turns out it's against the bottom line because the proper stakeholders weren't involved. Maybe the development was under unrealistic deadlines or timeline changes. We've all had to deal with this. Development in Cold Fusion is faster than most languages, but it's not instant. I can tell you that. A lot of people seem to think it is. Maybe the development team didn't have enough development expertise with modern Cold Fusion. What I mean by that is that some developers I've encountered start to fall into these comfortable patterns in their development process. They learned how to do something 10 years ago, and they've decided that's the best way to do it all the time. They haven't kept up with more modern Cold Fusion development practices. Maybe there wasn't enough money or other resources like Red Bull and pizza. Maybe the team didn't have the right tools or software environment or infrastructure to do the work properly. Maybe there's unexpected results from what was developed. And this one's interesting because many times we as developers are too close to the product. We look at it and we build what we're asked to build, and then a completely different result takes place when you put it in front of developers. We're too close to the product, too connected with what's supposed to be built, that we can't see how a fresh set of eyes is going to see the application. And believe me, if you don't take the time to put your application in front of some random user who has no background understanding on what the system's supposed to do, you're doing yourself an injustice, because watching users figure out your application is hilarious, and it's frustrating, and it's fascinating all at the same time. A couple of years ago, this video came out, and I play it in its entirety every time I give this presentation, just because I think it's hilarious, and I think that we've all dealt with this.
This is a square. Can you guess which spot that goes in?
The square.
That's right. It goes in the square hole.
Yes. Okay.
And how about this rectangle? That one
Also the square.
goes in there too.
Yeah.
Up next, we've got this thin rectangle.
The thin
Can you guess
rectangle.
where that goes?
The thin rectangle.
That's right. It goes in the square hole. And up next, a cylinder.
The circle.
I think that goes in
The circle.
the square hole. Now, we've also got this semicircle right here. Do you see a slot that would fit
The semicircle.
semicircle?
The semicircle.
That's right. It's the square hole. Okay. Up next, the triangle. We know what hole that goes
The
into,
triangle.
right?
Triangle.
That's right. The square hole. And up next, we have the arch.
The arch. The
And
arch.
you guessed it.
The arch.
It goes in the square hole.
You could just see the look of pain in that poor girl's eyes. And I've been there. So to remember, just test with your users to see if they're going to use the application as it's intended. So what can we do to mitigate these causes to prevent them from happening in the future? Well, first and foremost, plan. You should invest a significant amount of time planning, discussing, researching, preparing your approach to your application before you write a single line of code. Create a scope document. That's paramount so that every stakeholder understands specifically what is intended to be built. And make sure you bring in every stakeholder in that planning process so that you're not just coding blind. Even when you're managing a legacy application, incremental upgrades and refactors need planning. Planning is paramount. Nothing causes forced organic changes to an application more than fly by the seat of your pants decision making and a lack of planning. Now, take a reasonable amount of time to plan your changes, but don't chew up your whole time allotment and budget in the planning process. There's nothing worse than what I call bad horse drawing projects, where the time and effort is focused on a single phase of the development and the rest gets scaled back or ignored altogether. Plan, but don't overdo it with the planning. Next best way to maintain your legacy application, modernize the code. One of the easiest and best ways to open up modernization opportunities is to run the latest version of Cold Fusion. Some versions of CF have already reached end of life, which means they receive no new updates, no security patches, no bug fixes, anything. Newer versions of Cold Fusion also run faster, they enjoy new features, and they give you more opportunities to modernize a legacy application, which can improve your professional development. Many people aren't aware of the support and maintenance windows for Adobe Cold Fusion. All products are covered for 5 years from the date of release with an extended support window, which used to be 2 years in CF11 and earlier, but now it's only 1 year since CF 2016. What this means is that if you're running CF11 or CF 2016, you're already using an expired product that is end of life and considered obsolete. Core support for CF 2018 ends in just under a year from now. Tick tock. And if you're running CF 2021, you're covered through 2025. Michaela Light, she hosts the CF Alive podcast. She's an absolutely fantastic proponent of Cold Fusion. Great advocate for our community. She does CF State of the Union poll each year. One of the questions that she asks is which version of Cold Fusion is being run on your servers. The results are kind of unsurprising. Most of the community is running supported versions of CF. But as you can see, there's still statistically significant numbers of servers running 2016, 11, 10, even 9 or earlier. Looking at those numbers, though, that means that almost 40% of the Cold Fusion environments out there are no longer supported. That number's larger than it needs to be. And it makes me make this face, of course. Time to upgrade those servers, people. Technology and Cold Fusion have changed significantly. Remember, development's organic. If you don't nourish and grow, you're going to wither and die. I said there was an opportunity for professional development in updating legacy application. There's lots of new features in the newer versions of Cold Fusion that you want to take advantage of. CF 2018 introduced features like asynchronous programming, lots of array enhancements, component enhancements for abstract, final, default functions, and covariance. It also introduced the performance monitoring toolset, which, could have been its own release. It's a great tool to understand what's happening on your CF servers. There's also the lockdown installer, fat arrow functions, new query and array functions, so much more. And that's in the previous generation of Cold Fusion. CF 2021, of course, pushed the envelope even further and introduced all new features like the much smaller installation file that includes a package manager, cloud abstraction functions for Azure and AWS, modularization, that new lightweight installer, SAML support, CF setup configuration tool, NoSQL support, much, much, much more. So yeah, modernize your stuff. Some legacy applications were written years or even decades ago. Modern Cold Fusion is a robust, dynamic, capable language that gives you many opportunities to try new approaches, new techniques, and new methodologies. And it's going to make your legacy application more cutting edge, and it's going to improve your own skill set in the process. I just realized I should have started that animation before I started saying it. Thank you, Keynote. If you're intimidated by learning all these new tools and techniques, Luis Majano of Ortus Solution wrote a book a couple of years ago called Modern Cold Fusion in 100 Minutes. It's also available online at modern-cfml.ortusbooks.com. To be clear, it's written in a very Ortus way of development and pushes the cold box framework. But there's a lot of excellent information in there that will help improve and modernize your development approach. Great book, pick it up. Really easy to read and really fast. So let me put this another way. If your code looks like a late 80s yearbook photo, it's time to modernize. And let me show you what I mean. A few years back, I was consulting for a company that wanted to modernize their code. It was aging at this point, and I think that we're upgrading from CF9 to CF 2018. So I'm looking at the code, and this is kind of an example of what some of the code that they had in place looks like. As you can see, it's all tag-based. They've got a users function on line 3 that gives you the option to pass an ID, to retrieve a single record, or if you don't pass anything, you get a full list of users. They have a custom function on 17 that takes the query and turns it into an array of structures, because in CF9, that's what you had to do. This is all typical legacy code that you'd see that's out there in the wild. I mean, frankly, there's nothing specifically wrong with this. It's not as clean or as readable as it could be, but it works. You know, it's not that bad. So I did a first pass at making this a little cleaner and trying to modernize it a little. And the first thing we did was implement one of the features that came out in CF 2018. I think it was update 5. We rewrote the component and script. It makes it more readable, a little easier for modern developers to understand. At the time, 2018 had just come out with fat arrow functions, as you can see on line 17 there. This allowed me to eliminate the custom query to array function. Got rid of that entirely in favor of this fat arrow function that you can see on 17 to return the query as an array of structures. Now, at the time, I was so enamored with this approach that I wrote about it for the Cold Fusion community portal. Now, that was somewhat short-lived, because not long after that, Cold Fusion 2021 introduced the ability to set an option of return type equals array, which you can see I did on line 9, and this is the next iteration of that component. But this could still be simplified and improved. You know, I looked at this and I said to myself, why are you creating temp variables before you're returning the query? Why not just return the query directly? Use a ternary operator to have the variable where clause in the SQL statement. And this is what I ended up landing on. You know, it's small, it's concise, it's pretty readable, it does exactly what it needs to do. You know, you compare these two blocks of code, they do exactly the same thing, but leveraging the more up-to-date version of Cold Fusion with its new features and language enhancements, I was able to cut the amount of code significantly while making it more readable and more manageable. Now, some people may take away the lesson from this that less code is more modern code. And that's not necessarily the case. Less code does not mean more modern code. Likewise, less code does not mean more efficient code, which is crucially important, as you'll find out in the story I'm going to tell in a minute. So yeah, determine what areas of your application are ripe for refactoring. This is my third recommendation. Compartmentalize functionality where you can. Determine what parts can be reused. Bring in another developer, or pose a question to the developer community to bring in a consultant. Ask them how they would change the approach. Now, when it comes to refactoring things like this, a lot of developers tend to suffer from self-imposed scope creep. You know, you look at that component that I just redid. My advice to you is don't try to eat the whole burger. It's easy to look at the changes I just made to that CFC and to make it more modern and say, well, now we need to do that for all of our 300 components, each of which is 500 lines of code. No, don't let yourself get too overwhelmed when you're refactoring code. It's easy to do, especially when you're getting that satisfaction of making something better. Just remember that the goal of maintaining a legacy application is you're trying to leave things better than you found them. If your application grew over time and it wasn't well thought out, these small incremental improvements can help you retain your sanity. Okay, break time. Then we'll move on to our next group of issues. Okay, the second set is no documentation or code comments, no framework, no source control. I'm lumping the three of these together because they all cater to the same issue. And that issue is understanding two things when it comes to how and why an application was built the way that it was: context and intention. Okay? I'm going to give you an example. When you think of documentation, lack of code comments, lack of a framework, lack of source control, you have no idea what the context or intention of the application was. Here's an example. What's this? Is it a circle? Yes, it is a circle. Is it the letter O? Okay, it could be. Is it the number 0? Again, yes, it could be. Is it a donut chart showing 100%? Without the context or intention of what this is, me presenting this green circle to you on a white background, you have no idea what this is intended to be, right? Because remember, we're developers, we're not mind readers, which is why documentation and code comments are crucially important. You know, and believe me, there's a special place in hell reserved for developers who don't document or comment their code. And trust me, I'm going to be right there with you saying that was fun, because I'm terrible at documenting my own code. Why? Because developers write the worst documents. You know, like I said earlier, we are too close to the product to really be able to approach things from a non-biased perspective. How many people here have said to themselves, you know what, I'll document and comment my code once development's complete? Yeah, you're lying. You're lying to me and you're lying to yourself. I don't know of any developers who have ever actively gone back and said, yeah, now I need to go and write full documentation. In fact, there's only one company I've ever worked with that wrote really amazing documentation for everything that they did. Is a company called Shift4 Payments here in Las Vegas. And the reason why they did such a good job is that they had 2 people on staff full time who did nothing but document. They had a technical writer from the developer's perspective, and they had a technical writer from the user's perspective. And their documentation was amazing. Like, as soon as you were done building something, you would go talk to these 2 people, and they would ask you all these questions to be able to and write these complex, very detailed documents from both the developer and user's perspective. And it turned out great. But most companies don't have that. So we're forced to be able to write our own code comments, our own documentation. Because remember, we're developers, we're not mind readers. Unfortunately, sometimes we kind of need to be, okay? I'll give you an example. I worked with a company where one of the developers never commented their code. So I asked him one day, I said, question for you. How come you don't comment your code? And this is the response that he gave me. He said, David, look, if you're not smart enough to figure out what my code's doing, then you're not smart enough to be working here. And it was a little surprising. I was like, really? That's your response to that? But I responded to him. I said, look, if you don't understand that code comments and documentation are designed to answer the question, why is this code doing this, instead of what is this code doing, then maybe you aren't smart enough to be working here. We thought about it for a little while. I don't need a code comment that looks like this. Okay? Yes, it's a cat. I know it's a cat. I can see, I'm smart enough to look at it and say, this is a cat. What I want to know is, why is this cat here? Why does this cat look like it just snorted an 8-ball of Coke? You know, whose cat is this? This sort of thing. These are the things that you're trying to answer with documentation and code comments. I came across a piece of code where somebody had written this, and they put in code comment, sure, set A and B to be random numbers between 1 and 100, and then multiply them to hash the result. And I pulled him aside and I said, you need to do a better job here. This is not good enough code comments. And what he came back with was actually, I thought, a very good code comment. He said, you know, this code creates a hash based on an integer between 1 and 1,000,000. Okay. We use this in the user login system. When a user logs in, there's a similar function that gets run, and we compare the hash of the number generated at login with the hash of the number in their user record. If it matches, they've won the lottery and they get a special discount. Okay. We originally did this as random range between 1 and 1,000,000, but we determined that there was more randomness applied to creating 2 random numbers and multiplying them. From a code comment perspective, that's great. I understand the context, I understand the intention, and that's the important thing that I needed. My OCD was trying not to go berserk and say, you're wrong in multiplying them and hashing them because random range between 1 and 1,000,000 is just as fine. And why are you naming your variables A, B, and C? But I held back. I said, okay, I told him to fix the code comment. He fixed the code comment. Now, when it comes to context and intention, I'm going to tell you a little story that I call the nightmare scenario. And this is where our $100 Amazon gift card will come in, okay? I got hired by a company that said, we need you to come in. We just fired our developer. We had a single developer and we fired him. And nobody has any idea of how the code works. Nothing's documented. There's no code comments. We need you to come in and basically reverse engineer our entire application and tell us how it works. And I said, you know, I don't really know if I want to do that. You got a pretty big code base. And they said, we'll give you a truckload of money. I said, when do I start? So I start going through the code, and this is an example of something that I came across in the code. They've got a table, pretty basic, loop, query equals get ID, and they have variables, ID, ID, and ID details. And I'm saying to myself, I know what an ID is. Like, you're getting the ID of the record. Wait, what is an ID? What are ID details? And I'm thinking to myself that, okay, I really have no understanding of the context or intention of this, right? So I go to track down this get ID query. And this is what I see, okay? Pretty straightforward select statement from we're in a there's where statement. And I don't understand what any of these variables are, but then I said, wait, and I made this face. And this is where the $100 Amazon gift card comes in. So I'm going to ask you this question, and the first person who answers it in chat and says what the problem is with this will win that $100 gift card. So I'm going to give it just a minute here. Bingo, John. He used single letters for the table names. I'm looking at this and I'm going, wait, I is not aliased? And I said, certainly he didn't use single letters for the table names, right? So go into the database, and this is what I see. They've got tables A, AD, C, CO, E, I, ID, J, L, P, PN, R, S, U, and Z. So I went into the parking lot and screamed for a little while, and then I went back in, and I said to the guy who had hired me, I said, listen, this guy, like, I don't know what he did, but he had lunch with somebody here. He had friends here. Like, what did he do? He said, oh yeah, he talked to this guy, Sam, all the time. I don't even remember his name. He talked to Sam all the time. I said, okay, I want to talk to Sam. So I talked to Sam and I said, did this guy give you any insight onto why he coded the way that he did? And he said, yeah, he did it for two reasons. One, he thought that if he made the code really complex, he could never get fired. Okay, I get that. Dick move, but okay. The other reason is he thought that less code meant more efficient code. So he made everything one-letter variable names because he thought that made it faster. Remember when I said less code does not equal more efficient code? Yeah, here's an example of that, okay? Well, we did a bunch of reverse engineering, and it turns out this is basically what everything mapped to. A were accounts. AD were addresses. The tables in question, I and ID, were actually invoices and invoice details. And I was like, what are invoice details? Invoice details were actually line items. Okay, so he didn't even use the right terminology for it in order to know what it is. So we're looking at this and we're saying, okay, wow. Looking at this, ID is not the ID of the table. It's, or in the first instance, it actually is. But IID is the invoice ID. ID is the invoice details ID. And I thought to myself, why would you not just make this a little bit more verbose? Personal opinion, I can't stand abbreviations. just because it makes me think about what it is that this is trying to do. If you had just written it like this, so much easier to understand, so much easier to be able to go back in and know what is being pulled from what. Yeah, absolute nightmare scenario. Should ask for 2 truckloads of money. So what can we do to mitigate these causes to prevent them from happening in the future? Everybody hates it to hear it, but document. Knowing that applications are organic in nature, you know that this isn't going to be the last time that you or someone else has to manage that code. Write code comments and documentation to support what you did, and take some of the guesswork out of future development efforts. Future you is going to love you for it. Again, personal opinion, avoid obfuscation. Use variable names that make sense. My personal opinion is to avoid abbreviations. Try not to over-engineer your application. The more places that a developer has to look to find where the guts of that application are, the more time it's going to take to manage it. So if you've got includes that have includes that have includes that call a CFC that then calls a stored procedure, somebody eventually has to go track all that down to get to where the actual code is taking place. When I say try not to over-engineer, we're software developers. We do love to build cool and beautiful things, but sometimes you just need a bottle opener. Try not to over-engineer your application. This is me 100%. When I was early in my career, I like to make things really complex with abstractions and really make these elegant solutions. But now I just say, let me write this so that future me can easily understand it. And frankly, there's nothing wrong with this whatsoever. It's good to be able to write code in a way that you're going to be able to be maintaining it down the line, or somebody will. My next recommendation, set coding standards. The use of a framework such as ColdBox or Framework One are easy ways to set coding standards of how the application should be written. If implementing a framework into your legacy application is too heavy a lift, remember, don't try to eat the whole burger. Consider writing your own standards for code or adopting someone else's. The Ortus guys have open sourced their coding standards. You can go to their website and see, this is the way that we write code. This is the way we name variables. This is the way we use, we indent. It's very thorough and very nice. You can implement it pretty easily into any application. Now there's one last understanding of what to do with a legacy application sometimes. And that's knowing when to say when. Okay, there comes a time when the decision needs to be made whether or not to just scrap a legacy application entirely in favor of new development. It becomes a business decision based on the needs of the application and its longevity. Rebuilding it from scratch is the nuclear option. Sometimes it's the best one. A lot of developers I've worked with tend to move towards the let's just rebuild it. And that's a difficult decision to make. It's usually not one that the developer should make, because we tend to want to build these beautiful, crafted, well-architected, pieces of art that we think we can build from scratch when we see an application that looks like a complete nightmare to maintain. Rebuilding from scratch doesn't necessarily mean rebuilding in another language. The business is already committed a significant investment in Cold Fusion, so don't be too quick to abandon it. See if modern Cold Fusion, again, can provide that robust, secure, flexible platform to build the next generation of your application upon. So how do you know when you need to just nuke your application and say, okay, we're done? One, you need to understand your architectural limitations to your existing app. When a new feature comes by, when somebody comes in and says, how do we do that? Oh, our application wasn't built that way. It wasn't built to be able to support this. We didn't have users with multiple addresses in mind when we first designed it. Okay, that might be something that you consider saying, okay, we need to completely gut and redo this. Evaluate how much time you're putting into discovery. If a 20-minute fix to your application takes 4 hours of digging through the code to understand where that problem happened and what, if you're doing too much discovery to figure out where things are, know when to say when and say, okay, look, this is just taking too much time. Document where the known bugs and security issues are. That's always a big thing. It's always helpful going back to the documentation side to be able to say, here's where we know where we're going to have problems. And consider all the things that you do differently if you were to do it all over again. This is kind of that fantasy land that developers get into of, well, if we rebuild this from scratch, we could do it the right way. I've heard that so many times. And the second version of the application tends to have similar problems as the first one. So what have we learned? Number one, plan. You create a scope document. Very important. Try to think of much of the application through as you possibly can before you even do a single line of coding. Modernize. CF in 2022 is not the same as it was 10, 3, 5 years ago. It's not the same. Modernize your applications. Upgrade versions as well as the way you write your CFML. Refactor. Don't try to eat the whole burger when you do. Don't bite off more than you can chew. Don't take on these big, massive, we're going to refactor the entire back end, because it'll get too daunting to be able to really make a progressive impact. Remember, the goal is to leave things better than you found them. Document. It sucks. I don't care. Do it. Future you is going to thank you for it. Avoid obfuscation. Don't create any intentional bottlenecks to understanding the context and intention of why something was built the way that it was. Set some coding standards. Frameworks and coding standards put developers on the same page when it comes to process. And of course, know when to say when. Starting from scratch is sometimes the best solution. Now, I have one last piece of advice when dealing with a legacy application. Test, okay? Create local copies of your application. Create beta environments on hardware similar to production hardware. Write your own unit tests or use a testing framework like TestBox. There's no reason for you not to be developing and testing against a copy of your application. I can't tell you how many times I've walked into a company and they said, oh yeah, we just build everything directly on production. Don't develop or test against a live production environment. If you remember last year, HBO Max sent this out to like 1 million or 3 million of their customers all at the same time. Yeah, it's because somebody was testing in production and they tweeted about it. And fortunately, they had a good sense of humor. They, of course, blamed it on the intern. So yeah, plan, modernize, refactor, test. Those are 4 suggestions I have to decrease the chances that your application is going to grow out of control. And hopefully you'll be making less of this face. So I know that we are way early, but now that we've had a nice group cry about how much maintaining legacy applications can be a disaster, that's the advice I have for you. And hopefully these efforts will help make your development world a better place.
Right on. I think we have, we've got some questions for you in the old Q&A pod. Greg Stevens asks, how did David Byers, I assume he means you, not a different David Byers, create that awesome textured pie chart? I was actually wondering that too.
Yeah, Keynote. Apple Keynote has built in, you can create these 3D charts that animate and apply textures to. Really easy.
Very, very cool.
I don't understand the second question because it's in Russian.
I actually tried to translate that, and I was even more confused.
Fair enough.
Boris, if you wanted to resubmit that, that would be great. AE says, you mean start from scratch with not frameworks, or start from scratch moving the legacy code to frameworks?
If I were to build any new application, if I were to start from scratch on an application, I don't care how small it is, I'm going to implement a framework. It's either going to be Framework 1 or Coldbox. Typically, I go with Coldbox to start. They have lightweight versions of these frameworks that no matter what your application is, I wouldn't build a new app without a framework, because the importance of that framework is to put all of your developers on the same page. Imagine if you built something one way and another developer built something another way. It's like one person speaking English, the other person speaking German. And if you two both don't speak that same language, then you're just creating bottlenecks to application development. As soon as you use a framework, you're saying, okay, here's the standards, here's where everything needs to live, here's the way that things are going to be developed, here's where your data models are, here's where your views are, so on and so forth. It just puts everything on the same page to be able to be more efficient, especially in multi-developer coding environments.
That's a good point. Yeah, I find it difficult occasionally when dealing with these folks to just get people to understand how valuable it is to move to a framework. They're just not comfortable with it. They don't know it. They feel like, oh, our totally like chaos ball code is totally better than this framework that has been, designed to be efficient and effective and scalable. Why would we move?
Right, exactly. So yeah, it's critically important to use a framework. I can't recommend it.
So Boris asked us in English. Okay, a question for you: how long will CFML survive? What's your opinion on that?
That's a great question, and it's one that I stirred up a little bit of controversy last year when I wrote an article for the community portal called "Cold Fusion Needs to Die." Because here's my personal opinion on Cold Fusion. I think that Cold Fusion will be around for at least another 10 to 15 years because there is a passionate, dedicated developer community that loves this product. And I know that Adobe is dedicated to this product. So at least another 10 to 15 years. That being said, again, my personal opinion, I think that Cold Fusion has a reputation problem. Many companies that I have worked with or discussed with, they say, oh, we can't use Cold Fusion. It was built 25 years ago. They don't understand modern Cold Fusion. They don't understand that it's, Cold Fusion of 2022 is not the Cold Fusion of 2015 or even, any time before then. I think it's going to be around for a long time because I'm dedicated to it, and I know many people that I have worked with and talked to are dedicated to it. It's still the fastest way to develop applications that I've ever experienced. And, I've worked with a lot of different languages. Cold Fusion is still my personal favorite because I think it's going to be around for a while.
Very cool. And if I have anything to say about it, forever, until I retire at least, right?
Yeah. Yeah, I mean, fingers crossed. I was at the first CF Summit, and I've been to every CF Summit that they've had because I live in Las Vegas. It's very easy for me just to go down to the Strip and hang out for the day. The first CF Summit, they had 500 developers there in person, and I thought, this is great. Next year, I'd love to see 1,000, and the year after that, I'd like to see 2,000, and the year after that, I'd like to see 2,500. We're a small community of developers, which is one of the biggest challenges that companies that use Cold Fusion face, is finding proper Cold Fusion talent that knows how to get things done. It's a tug of war, in my opinion.
It is. There is a difficulty, and I mean, I'm like ground zero on that, of course, because for me, it's we can't hire enough Cold Fusion developers on the one side, and on the other side, we've got folks. Well, I don't want to learn Cold Fusion. There's no jobs, and I'm like, wait,
right?
You're just like talking. People are talking across each other, but I mean, things like what we're doing here, you coming in and talking about these legacy code sets and how you can make them better, is a really big deal. This will prevent in the future people from going, oh yeah, I worked in Cold Fusion and the code set was awful because it's Cold Fusion, which is not true, but it was because it was legacy. And if more and more people come to talks like this and come in and implement frameworks, implement modern patterns, I think it's just good for the ecosystem long term.
It makes a big difference.
I've got a question here, and this one definitely is like a 5-second answer easily. How can you go from standalone CF servers to using the framework model?
You think that's a 5-second answer?
No, I was just totally messing with you. No, that's a pretty big one there, Stephen.
Yeah. I mean, the first thing is understand from a standalone CF server, if you've got it like sitting on a server somewhere, either locally or in the cloud or whatever, get a local development environment. Or spin up a Docker container that using the Cold Fusion Docker images, and port your application to somewhere where you can start making those incremental changes. Make sure you're implementing a code repository like Git or Bitbucket. This is a self-promotion here. I put in a suggestion for a session at CF Summit where within 1 hour I was going to build a local development environment running Docker that would push to a code repository that would use a pipeline to automatically deploy the code to production servers within 1 hour. They haven't approved me yet, but
yeah, well, I was looking at that, and I think I will approve you as long as you agree to have me throwing water balloons at you while you're doing that, because we need to like Vegas it up a little bit.
Bring it. Let's make it a duck and move.
Duck and move. Yeah, got to be agile, right? This is what this is all about.
Duck and move and code and build servers and all sorts of fun stuff.
All right, we got another question, and still got plenty of time here. So Steven Sykes asks, I'm the only IT guy in a small company, so my CF style hasn't changed much over the last 20 years. Feel that for sure, Steven. Does it really matter? And I think what he's asking, does it really matter to modernize? He's trying to modernize, but it's tough with apps I've been developing so long. I think a lot of us have run into that. So that's a good question for you, David.
Yes, and that's a fantastic question. Because I've experienced this myself when, go into a company and you see the way that somebody's coding something, and it's like, oh, I've coded it this way because I learned in 2004 how to do it, and that's just the way that I've always done it ever since. Is it important? Adobe does an amazing job, and the development team does an amazing job of making sure that every version of Cold Fusion is very backward compatible with the previous generations. That's not to say that it's permanent or lasts forever. There are some features that get deprecated. Cough CF pod. See? So, it's important to professional growth. If you want to grow as a developer and be better at what you do and modernize your approach, because, I'm paranoid by nature. One of the things that I ask is, what happens if I don't have this job tomorrow? Can I go into another company with the expertise and the approach that I use now and still have a marketable skill? If I'm coding the way that I was 10 or 12 or 15 years ago, probably not. But that being said, is there anything specifically wrong with doing anything? If you look at the code example that I gave earlier, where it was all tag based and they had a custom function to be able to query to array of functions, that all works. It does exactly what it needs to do. There's nothing specifically wrong with that approach other than it's not keeping up to date with the times.
Yeah, and if I could add something too, I mean, if you know that way of coding and you're hired by a company that has a legacy code set, you actually have a little bit of an advantage versus someone who learned only the modern CF script style. You'll look at the tags and go, what in the world happened here, right? Having said that though too, I mean, I totally agree, David, like you need to keep learning. And even the tag stuff, we update that, right? Like we add member functions to tags. Things have changed even in the tag side of things. So just kind of staying in a time capsule in the past is probably detrimental to your future career growth opportunities, even in the company you're in, right? So so AE also asks, yes, but legacy code moving to a framework is like starting from scratch. And that's a good point.
It can be. One of the largest applications I've ever worked on was all, single pages, everything, their source control or their reuse control was just CF includes. And one of the things that we did was start to migrate that to a legacy, that legacy app to a framework. And especially when you're dealing with older legacy apps where each page is its own application, it makes it almost easier because you can migrate some without migrating all. Is it like a start from scratch? Depends on the approach. It depends on how much you can compartmentalize those functions into, we're going to build this one in the framework. The rest of the application is still going to live in its legacy, whatever it needs to do. I've seen groups that actually have run different versions of Cold Fusion on a single server, one that's running their legacy app, and then the new version is running their new code, and it just kind of weaves back and forth in between. So is it like a start from scratch in some ways, but it doesn't need to be.
And this reminds me too of this idea of moving very, very large monolithic code sets to microservices as well, right? People say, "Oh, I can't do that. I'd have to break up the entire thing." And no, you don't, right? Like you said, if you compartmentalize it, you can move piece by piece. And if you're moving it anyway, you could use a framework, and you should use a framework. So
yeah. Don't try to eat the whole burger.
Don't try to eat the whole burger. I'm getting hungry here. I've got an hour till lunch on my side. Oh my goodness. All right. Well, I think we're kind of getting here close. Let's see. We got one more question. I think we have time for it. Jared Krogman, as a single CF developer within my org, I know I need to grow and expand. Being isolated, I need a CFDW to learn what I don't know. I'd be very interested in a 1 hour or more session moving from a single legacy developer to a modernized team of developers. That's a
great idea.
That's a really nice topic idea.
That's a great idea for a topic.
I like it. So JR, your job is to learn how to do that and then give me that topic and come to Summit and give that talk. And we will pay for your hotel stay, your Summit ticket if you do that. Awesome.
I think Mark just told you figure it out yourself.
I did, sort of gently. No, I mean, and it's one of those topics that I think is extremely difficult because of the wide variance in what company structures look like, right? Like, it's hard to create a one-fits-all type of situation when you're talking about people, because we're all
right.
different.
And honestly, I think, again, blatant self-promotion. I think that's one of the reasons why I wanted to do this session at this workshop at Summit, is because a lot of developers are the single developer in their organization. And, imagine having that framework where you can develop locally on your own machine, and then push code and have it push automatically to servers that are your production servers, but you have that environment to be set up to be able to do all the testing and make the mistakes without actually working on your production environment.
Well, and I can tell you right now, there's actually someone that's in this room but has been very, very quiet. Someone I work with named Chin, who works for one of the universities nearby here. And I know that he and his team literally have been going through the process of doing what you're talking about, creating local development environments, using containerization to try and essentially create repeatable, growable, scalable development stations to then move that code up to production in the same state that it's in, essentially. And there was some struggle there because I think no one's really done a talk like that quite yet. So if you're down with the water balloons, I think maybe I'll talk to Kishore later and get you approved on that.
What? I'm down. I can do it. Sure.
We'll just have to, we'll waterproof your laptop and bribe.
Hey, I live in Vegas. You don't have to pay for the hotel.
That's true. I'll have to bribe security to not kick me out, though. All right. Fantastic. Well, I'm going to move us to the outro here just so we can get some votes in for David's talk. It was amazing. What a talk. I really, really want to thank you for coming in and bringing your energy. I always love to hear you talk. I know everyone else here does too. And I look forward to seeing you in Vegas. So coming up next in just about, I think it's 30 minutes, maybe 31 minutes. Let me check my schedule. Yes, 30 minutes. We have got Brian Buckold exploring AWS Java SDK developer features using the Java integration implemented in CF 2021. So that is going to be a scorcher of a talk. Hopefully you all stick around for that. Meanwhile, please vote, and we'll be back in the lobby in just a few minutes.